Welcome to Lecture 2.8, Linear Inequalities. So if you refresh your memory, we did have a lecture on equality, linear equations. So those were equalities versus inequalities. Inequalities are less than, greater than, less than or equal to, and greater than or equal to. So when we had our equality, we had an addition property of quality, and we now have an addition property of inequalities. So for any algebraic expressions, A, B, and C, if A is less than B, then if you add the same amount to each side, it is still a true statement. So A plus C is still less than B plus C. So adding the same quantity of an inequality will not change the solution set. So let's solve an example. X plus 5 is less than 7. So first, we're going to treat it the same as we would if that was an equal sign instead of a less than. I'm going to subtract 5 from both sides. So I have x is less than 2. But what does that look like on a number line? So if I have this number line, I'm going to put a circle around 2. It is an open circle because 2 is not included. And then I'm going to just draw a nice line to the left because it's less than 2 with an arrow because it's everything less than 2. Not just up to -2, it's everything less than 2. Let's try another problem. X minus 6 is less than or equal to -3. Again, we're just going to treat it like it's an equal sign at first. Add 6 to both sides. Now, I have x is less than or equal to 3. Now again, what does that look like on a number line? First, it does have equality. It's less than or equal to. So I'm going to make a solid circle on 3 and then draw a line to the left because it is less than. So if you want to the left, you say less than, to the right is more than. So let's work through this problem together. So x minus 2.6 is greater than 10.4. First thing I'm going to do, I'm going to add 2.6 to both sides. And now I have x is greater than 13. Okay. But again, I need to sketch out what that looks like. So I know that we're dealing with 13, so I'm immediately going to draw a circle around 13. And I don't include 13 because there is not an equal sign, but it is more than, so it must go to the right. So if I just kind of make a line dark enough to where you can see what I'm talking about, and an arrow, then you'll see that it's greater than 13, but not including. It's an open circle. It does not include 13. Let's work through one more problem. So 2 is less than x minus 7. So first thing, let's use our addition property. So 9 is less than x. But that's a little difficult to understand, or it would be easier if the x was on the left. So I'm going to just switch the whole entire thing around. X is greater than 9. The small point was next to the 9. The small point is still next to the 9. Now let's sketch that on the number line. So it is greater than 9. So it's just a circle around 9 because it's not including 9. And it is greater than 9. So I want to make the line going to the right. Now, just as we had a multiplication property of equality, we have a multiplication property for inequality, but it is just a little different. Okay? For any algebraic expressions, A, B, and C, if A is less than B, then A times C is still less than B if C is positive. And A times C is now greater than B times C when C is negative. It's a little difficult to understand at first, so let's see a problem in action. 3A is less than 15. Okay. We're going to treat it just as a normal problem. So we're going to divide by 3. Now A is less than 5. And on the number line, it doesn't include 5, so I leave an open circle. And it's less than, so I draw to the left. Okay. Now let's try, that was kind of like a normal problem. I divided by by a positive number, so nothing changed. Negative 3A is less than or equal to 18. Now, the first thing I'm going to do is divide by negative 3. But since I'm dividing by a negative, I must change the direction of my inequality. So now, see, it was less than or equal to, now it's greater than or equal to negative 6. Let me walk through that again. When I divide or multiply, because I'm really multiplying by negative 1/3, when I divide by a negative number, you switch the direction of the inequality sign. So right now it's less than or equal to. It turns into greater than or equal to. And then I just do the division. 18 divided by negative 3 is negative 6. So on the number line, it's negative 6, and it does include negative 6 because there is equality in here. And it's greater than, so it's everything to the right. Now you notice my number line, I've skipped some numbers. As long as I have enough information for you to understand what direction it's pointing in, that's okay. I don't need 100 numbers to figure out what direction this is heading. Let's try another problem. Negative 8x over 4 is greater than 2. And when you think about this, what's really happening to the x? It's negative 1/4. So if I multiply by its reciprocal, it's a negative 4. What I do to one side, I must do to the other side. But I'm multiplying by a negative number, so I am forced to change the direction of the inequality sign. So it becomes 8 is now less than negative 8. Again, let me walk through this one more time. When I multiply or divide by a negative number, I must flip the sign of the inequality. So multiplying by negative 4 to each side, right now it's greater than, it becomes less than, and then I do the math. Negative 4 times 2 is negative 8. So x is everything less than, but not including, negative 8. 2.5x minus 3.48 is less than negative 4.9x plus 2.07. So there are two methods of solving items with decimals. The first way, I'm just going to run through with the decimals. So what I want is all the variables on one side of the inequality, all the constants on the other. So I'm going to add 3.48 to the left as well as 3.48 to the right. Now I have 2.5x is less than negative 4.9x plus 5.55. Now I want to add 4.9x to each side, and since I realize that we're moving an x around, but number one, we are adding it, we're not multiplying or dividing, so we're going to leave the inequality alone. So I'm going to add 4.9x, add 4.9x, giving me 7.4x is less than 5.55. Now, if I was going to change the sign, this is the time that I would do it, but I'm dividing by a negative number, so the sign remains the same. Divide by 7.4, 7.4, x equals 0.75. Okay. Now, how do I draw that on the number line? I'm just going to put enough information, and I shouldn't say equal, it is not equal. It is less than. That was my error. So I have a 0 here. Maybe I have a 1 over here. Now if you divide it into 3, 0.75 is going to be right there on the number line. X is less than. It does not include it, so it's an open circle. And it's everything to the left. Again, you want to put enough information to where your number line can be read. Now method 2 is getting rid of all the decimals. So I'm going to multiply everything by 100 because I have 2 decimal is the largest. So I'm going to multiply the right side and the left side by 100 just to get rid of the decimals. Okay. Now I can rewrite my problem as 250x minus 348 is less than negative 490x plus 207. And the process is the same as it would be if there were no decimals, because there are no decimals now. So add 348, add 348, giving me 250. X is less than negative 490, x plus 555. Add 490x, 490x, and I am left with 740x is less than 555. Again, divide by 470 this time, 740, pardon me, and x is still less than 0.75. Whether you change it or not, it's still going to be 7.75, and your graph would look exactly the same. Maybe you have a 0, maybe you have just the 0.75 out here. Again, enough information to allow your reader to know what your x value is doing. So x is less than 0.75. So that's it for part 1 of this lecture. I am going to work through a couple more examples in part 2 of this lecture. So until then, be seeing you.